Thank you, and good morning, everyone. And actually, I have a speech, so I timed it. It's exactly 10 minutes. So I think you'll be relieved, unless I digress, which I've been known to do from time to time. But good morning, everyone. It's very good to be back to University of Michigan, to the Automotive Research Center, and also to my former department of mechanical engineering, where I spent 20 years. And I'm really delighted to see all my former colleagues here. Of course, all of us are a little older. That's the other side of the coin, except for Anna, of course. So today I've been asked to reflect on the Automotive Research Center since it started 20 years ago, especially since I've stepped back from it since 2005, and I'll try to present it from my perspectives as a former dean of engineering, and also now that I've crossed to the really dark side of administration, to university, the point of view of university administration. But essentially looking at what the ARC has brought me personally during my career, but also what it has brought to TARDEC and the universities and overall the world of science and engineering. So I'm showing here just as background some slides of case studies that we did in the trust area, some case studies that ran across the Automotive Research Center. So I was Associate Director of the Automotive Research Center from its creation in 1994 until 2005. As you know, the ARC was organized in trust areas, and I served as a leader for trust area modeling and simulation of vehicle structures. That was from 98. In 98, that trust area was enlarged in terms of its research agenda, and it was made a little bit more modern. And we came up with the name High Performance Structures and Materials. That was quite an achievement to find that name already. So I'm going to go through some of the things that the earlier speakers said, but maybe with a slightly different perspective. At its root, the ARC is really a partnership between the University of Michigan and TARDEC, and it's really the result of the foresight and the vision of several individuals. They've been named earlier. One of them is Panos Papalambros, who was the chair of the Department of Mechanical Engineering at the time. Another one was Walt Bryzek, who was a chief scientist at TARDEC. And there were others like Ed Haug from the University of Iowa and several other government, university, industry leaders. So in 1993, I remember pretty vividly that Panos tasked a few faculty members, I was one of them, I think Jeff Stein, some others, to each put together a research group, and start defining a research agenda for a trust area of what was going to become the ARC. We did what we could, we did our best, but this was pretty new to us. We were really used to working in our own silos. And for a while, we went to Panos with our proposals, and it was back to the drawing board until we got it right, and we came up with a coherent proposal. During that time, Panos was working pretty intensely with TARDEC and others to put together a funding model, the operational model for the ARC partnership. And I have to say it was an exciting, I would even say exhilarating time in the Department of Mechanical Engineering. So the concept of the ARC was, I would say, quite disruptive at the time, but it really forced us faculty to think and to work in very different ways than we were used to. Since then, I believe that the vision that really led to the creation of the ARC has been vindicated. And to this day, the legacy of the founders of the ARC remains. The ARC was the avant-garde of what was to become the model for large research centers in the US. In fact, the two large public-private manufacturing innovation institutes that were announced by President Obama in February do share and both led, one by university or inspired by the University of Michigan, the other one by the University of Illinois. They do share the very foundation several of the key attributes that have made the ARC a success for the past 20 years. And there are two innovative principles, which I believe now pretty much taken for granted, but in 1993 that was not necessarily the case. One of them is that since its inception, the ARC has been really the epitome of interdisciplinary research, before the term interdisciplinary became fashionable and commonplace and a must throughout academia. So we all had to work together, people in dynamics, in control, in materials, in acoustics, propulsion, heat transfer, durability, design, ergonomics, and so on. The second principle is that the ARC was anchored really in a partnership between government, academia, and industry. And these things, again, were pretty novel and somewhat disruptive in 1994. One key to the success of the ARC is the expectation that each year at the ARC program review, the various trust areas get together and present a case study that showcases the latest advances in modeling and simulation. And this was, and I think still is, a mandatory exercise. And it really had the de facto effect of enforcing that requirement of interdisciplinarity for the ARC. And of course, we did a lot of our research in silos, in disciplinary silos, but at the end of the day, our research results had to fit with those of our colleagues within and without the trust area to yield really a modeling and simulation product that was demonstrated through these famous case studies, and sometimes dreaded case studies, I have to say. Another key in the ARC model was, as you know, the creation of the quads with a faculty member, a TARDEC researcher, an engineer for industry, a grad student, or a postdoc. Again, requiring, the idea of the requirement, that it's not an option, that each ARC project involves principles from these different places. So many research centers have adopted now similar modes of operation. And really, when you take these two keys together of interdisciplinarity and working together with industry and government, these two keys really made me as a faculty member. It forced me to leave what I would call my very comfortable and successful sandbox of my own field of dynamics and vibration. And it really forced me to work with faculty in very different areas, and that's sometimes uncomfortable, it's difficult, but you get a much richer perspective that way. I'd like to make a couple other points, and they've been made already in some way. One of them is that the ARC, and I come from a relatively theoretical background in my research, but the ARC for me was very effective in asserting that research in engineering didn't need to be esoteric. And there is still, in academia or some parts of academia, really a tendency to be as theoretical, as abstract as possible. But the ARC really promoted the fact that research has to be done for a purpose, such as improving the design and performance of ground vehicles that are used in the Army. So in my opinion, the ARC agenda really helped dispel the myth that applied or relevant research is dirty, and that naive view that only theoretical research is pure. And we know that's not true. And we know that many fundamental advances are actually the results of discovery that are made by studying actual industrial engineering systems, and that basic and applied research go hand in hand. So to close, let me mention a couple of areas in which I believe the ARC had a significant pioneering impact, or at least a couple of areas to which the ARC contributed significantly, because there were a lot of things happening in the research world around that time. The first one, and they're related, but the first one is that really the ARC promulgated a market shift from what had been a traditional experimental-based approach to an approach relying primarily on modeling and simulation. So really the ARC really helped set the trend in what has been a revolution over the past 20 years in the world of research and development to give modeling and simulation a preponderant role, and of course to complement pointedly this modeling and simulation, these models, with experiments that validate component models. And that revolution has taken place in automotive engineering, but also aerospace engineering in terms of designing and building new aircraft engines or aircraft. It's been phenomenal. The second point, which is related, is that the ARC was really a precursor in putting forward the concept of reduced order models. And it became very clear when we were putting together the proposal in 1993 that all the computational power in the world could never really handle the complexity of the discipline-based models that we were developing. And even though computational power has increased manifold since, we always want more. We always want more accurate models. And really the key is to develop reduced order models which are as small and as simple as possible and as inexpensive to simulate as possible, but they have to embed enough of the complexity so as to replicate the imponent physics. And that reduced order modeling, which you apply at a component level, right, for components such as tires or tracks or engines or frames, automotive frames. You can see my aerospace band here. But also for physics, right, physics such as vibration, acoustics, impact or fatigue or noise. These reduced order models really are critical, and we were very proud to have been, we had this gigantic finite model, which seemed large at the time. Now, at least I do a lot of work on aircraft engines, and we deal with models with tens of millions of degrees of freedom, with nonlinearities and contacts and friction all over the place. And we were very proud to reduce this model to about 2,000 differential equations and get the vibration behavior over a large frequency range. We've gone much further than that now, much more powerful. But really, this idea of reduced order modeling was absolutely key, and I think it's been very pervasive in many areas. So to conclude, I would say really the ARC is a prime example of the broad and the lasting impact that a few visionary leaders can have. I would call it really a case study in leadership. And happy birthday to the ARC.
I want to thank this community for what you've done to make our vehicles survivable, dependable, and durable. And using the words of Paul Rogers, thank you for bringing us home safely.